If you grab a pew, we'll get underway. I think we'll start anyway. Less of me, more of him. Someone originally from Cork. 22 years with Wilkin and Sons, must have been on day release from school, about 14 when he joined them. And of course the Worshipful Company of Fruiterers, one of the Grand Fromages at there. So less of me, more of him. I give you Chris Newenham. Chris, morning.
Right, good morning everybody. For those of you who haven't got your headphones on, if you I think there's an explanation going. So I'm here to represent the Worshipful Company of Fruiterers. The Worshipful Company of Fruiterers are tasked with promoting excellence across all sectors of the fruit industry, supporting education and research within the fruit industry. We're active in fundraising and giving to charity. We support and promote the City of London and generally try to foster a spirit of good fellowship and encourage new membership. Today is an opportunity for us to showcase some of the scholars that we have supported in recent years. So we're delighted to have Cindayniah, Samantha and John, who will be supported towards the end by Minette Batters. So thank you all for coming and for listening, and I'm going to hand over to Nigel.
I tell you what, these headphones are bloody marvellous, aren't they? I mean, I've got to be very careful what I say because you're absolutely picking it all up. There you go. I know first up, Cindayniah as well. Control options of woolly aphid, but also studied at uni in Birmingham, biological sciences, and in Berlin. Well done. Integrated pest management and so much more. I know I'm your weird stalker. There you go. So, wait till we get on to Samantha and John. Even more stuff to talk about. But so yeah, Samantha Lynn and John Gray will be on after, and then the one who will be trying to follow in their wake is that Minette Batters. I hear she's quite good. She's going to be on 11:30. But less of me, more of her. I give you the very special, very talented, and the very here on a Wednesday of a National Fruit Show. Cindayniah Godfrey, hello, welcome.
Okay, hope everyone can hear me. Thanks for that introduction. Yes, so I'm Cindayniah. I am. There I am.
Very good.
Perfect. So I'm a PhD student in my final year. I'm working with Simon Seager and Tom Pope at Harper Adams University and Michelle Fountain and Feli Fernandez at NIAB at East Malling. And my project is titled Resistance and Susceptibility in Interactions between Apple and Woolly Aphids. So today, just a bit of an overview of what I'm going to talk about, a bit of an introduction to the pest, what the aims of this research project were, a bit about the rootstock breeding programme at East Malling, how we're working with that, a little touch on resistance breaking aphids, which are a bit of an emerging problem, a little bit of an overview of the woolly apple aphid life cycle and how that has affected digestive diversity, and then just some final conclusions at the end. So introduction to the woolly apple aphid. So it's originally from North America, but it's fairly widespread around the world now, especially in major apple growing regions. It's been in Britain since 1787, so it's quite well established here. It forms these really distinctive white colonies because they produce this waxy, so wool we call it. And it feeds on quite vulnerable sites mostly, so pruning injuries and new growth. In terms of damage, so unlike some other crop varieties, you're all right? Okay, unlike some other crop varieties, it doesn't transmit any viruses, which is good news, but when they're feeding, they inject saliva into the plant, and there's molecules within the saliva which cause the tissue around the xylem and phloem to start proliferating really rapidly, forming these galls, and they can completely block water and sap transport around the plant, which is it makes especially young trees very, very vulnerable to stunted growth and reduced yield. Those galls are also, because they're injury sites and they can kind of split open, they act as entry points for fungal pathogens such as canker, and woolly apple aphid feeds over the whole tree, so they make the entire tree very vulnerable. And as with a lot of aphid species, when they feed, they produce honeydew, which can cause sooty mould to grow, which if it grows on fruit stops them being marketable, and also can reduce photosynthesis and therefore growth and yield. So current control options for woolly apple aphid, on the scions, the above ground portions, we have got some control options. Normal sort of traditional contact insecticides are blocked by this fluffy wax that they have. There's the best option really is spirotetramat, which is a systemic pesticide. So when you spray it on the plant, it travels through the plant and affects aphids feeding at every point, which is great because it can also target aphids feeding on the roots. There are natural enemies available, kind of normal aphid natural enemies, ladybirds, hoverflies, earwigs. The big problem with the aphids that are feeding on the roots is that they're very difficult to monitor and control. Best agronomists in the world can't see underground. So the role of resistant rootstocks, which completely prevent feeding, means that you are eliminating the need to control underground because that's taken care of as soon as you put your rootstock in. And it also removes an infection source of woolly apple aphids, so where they can't build up under the soil out of sight with a resistant rootstock. And they're a really key portion of an IPM strategy for the aphids in this way. So there were kind of three main aims of this project. The first aim is to look at a genetic mapping of resistance genes in apple for woolly apple aphid, and the second aim is to look at woolly apple aphid genetic diversity, and I'll touch back on both of these points. And then these will hopefully, through this project and in the future, come together to allow us to breed rootstocks with a durable woolly apple aphid resistance to multiple different types of woolly apple aphid. So with the rootstock breeding, we're working with the rootstock breeding programme at East Malling. So far, for the groups all around the world, they've identified 4 resistance genes and other sources of resistance. So a lot of crab apples actually have natural resistance, but no one's had a chance to fully sort those out into resistance genes yet. We're looking at 2 main resistance genes, which are called ER1 and 2. So one comes from Northern Spy, which is a scion variety that's quite popular in North America. It's not massively popular here. And we know exactly how that is resistant. So all it is it has a thickened tissue around around the vascular tissue. So when aphids are coming to feed, they just physically can't get through that. And that has been used in commercial rootstocks such as M116 and MM106 from the Malling-Merton rootstock line. And we also have ER2, which comes from the crabapple variety Robusta 5, and that is used in a commercial rootstock line from Cornell University in America. So, for example, Geneva 41 is quite a popular rootstock with this type of resistance. So what we're trying to do in this project, we've taken seedlings that are really clearly resistant to woolly apple aphid, so woolly apple aphid won't grow on them at all, or that are really clearly susceptible, where they're absolutely dripping in aphids. And what we're doing with those two different extreme types is we're looking at differences around those resistance genes between those 2 types, differences in the genetic markers. So as you can see, where I've put the red bracket, this is from previously published work, there's a lot of empty space around those 2 genes, and what we're looking to do is identify markers within that space. One big role of most breeding programs at the moment is a thing called marker-assisted selection, where currently I had to find those trees that were dripping in aphids or completely bare of aphids, and I had to physically put aphids on them, wait 2 weeks, see how the aphids grew. Whereas with marker-assisted selection, all you do is you just take a leaf disc, extract the DNA, and then you look for that genetic marker, which you know is next to your gene of interest. So it's much quicker, much less money and labour involved. And the smaller the range we can get, the more sure we can be that we have the gene is detected by that marker. So this work is still ongoing because I'm still analysing that data, but hopefully we'll be able to use that in the future to feed into the commercial rootstock breeding project. The reason that this is getting to be a bit more of a concerning issue is that recently we're starting to see an increase in reports of aphids feeding on those commercially available resistant rootstocks that I mentioned. So they've been available, or they've been reported all around the world for about 50 years, but quite sort of isolated instances. We're starting to see them more and more in Europe and more in Britain anecdotally. They've been able to feed on both those M116 and MM106 rootstocks that are quite widespread here, but also on the American line. We think that it might be that varying environmental conditions kind of benefit the aphids, which is why it's mostly been seen in the southern hemisphere so far. But obviously with warming climates, especially in places like Kent, we can expect to see kind of more beneficial conditions for the aphids in the future, which might lead to seeing this trait more widespread. So the kind of So moving more on to looking at the genetics of the aphid. Normally aphids, a bit of background, normally aphids would switch between two hosts in the autumn and the spring, which woolly apple aphid does do in America, but for some reason doesn't do anywhere else. So where it's lost that stage, on the diagram, which is so spring, summer, autumn, winter, but also the position of the aphid on the tree, they move down to the roots in the autumn, and they would normally at that point, a separate group would go off to do sexual reproduction, but where we've lost that, we're getting increased build-up on apple trees, which is an extra pressure, but also where we've lost that sexual reproduction stage, we think that they are mostly reproducing asexually around the rest of the world, which would be good news because it's much more difficult to spread genes around an asexual population. We have sexual reproduction to increase genetic diversity, and so without that we expect to see not a lot of diversity. But we are starting to get reports of sexual woolly apple aphid found around the world and in Britain. So what we wanted to do with this project was look at how much variation we actually have in Britain, and is it likely that we have sexual reproduction here because of the concern that then we would have the ability to spread those virulence traits. So we collected samples from commercial orchards, research sites, and other kind of miscellaneous sites like random crabapple trees, gardens. And we looked at a couple of other countries, but we mostly looked within England. And we have the hypothesis that sexual reproduction increases genetic variation. So if we see high variation, we think that there's sexual reproduction. And we haven't seen it yet, but there's obviously always the potential that they could start spreading insecticide resistance around if they are doing a lot of sexual reproduction. So we collected samples from four major apple growing regions. So North America, Chile, the Netherlands, and New Zealand, and all four of these countries grouped completely independently. So we're seeing international variation, which is great, kind of hypothesis one ticked that we see variation around. Then looking wider within the UK, we collected samples from West Country, Hereford and Worcestershire, Cambridgeshire, a little bit from Northern Ireland. We saw that the Somerset samples were grouping together. They're collected from 2 commercial sites and a garden across 3 different years, and they still all group together. We also found this one unique population in Walton-on-Thames in Surrey that was just on a random ornamental crabapple, just was a completely unique population. So a bit weird, that one. And then looking more closely in at Kent, where most of our samples came from. So we found another unique population at an commercial orchard near Staplehurst, and then we found incredibly high genetic diversity at the National Fruit Collection and at East Malling. So why do we think that might have been? We think that at those 2 sites there's a lot of variation obviously in apple varieties. We have a lot going on, but Brogdale also had at the time elevated temperature tunnels. They were looking at the effects of climate change, so it's possible that, as I said, with the southern hemisphere, that the warmer environment there was benefiting the aphids and that they were able to sexually reproduce more. We did find some completely isolated populations in the UK, which we'd expected where they're reproducing asexually, as we thought. But we did find a lot where they were really highly mixed, which leads us to think that there probably is some instance of sexual reproduction occurring here, mostly, but not exclusively, at these research sites, which is good news for growers and probably what was expected, but it is alarming that they can do that, and woolly apple aphid are mostly actually spread on infected rootstocks. So if we were spreading, if we sent that material around, we could really easily spread this trait. And as I say, the real concern for that is spreading this trait around. We can't say definitively, but it looks like that is a bad sign at the moment. So just some conclusions on what we've found so far. As I say, the kind of rootstock breeding portion of the project is still ongoing. We are looking for better genetic markers associated with those genes, with the long-term aim of feeding resistant rootstocks into commercial release. And then with the woolly apple aphid population genetics, we do think there probably is some sexual reproduction in the UK, which is a concern for spreading these virulence traits. We can't say certainly, but it's just something to look at for the future. Some quick acknowledgements. To thank the Worshipful Company of Fruiterers for inviting me here today, and also for the David Honum Prize. And my supervisors at NIAB and at Harper Adams University have been really useful throughout this project, as have especially the Farm and Glass team at East Malling and the Genetics, Genomics and Breeding department. my two industry reps. So we're on an industry funder programme. So Lorraine Boddington and Shanae Butcher, and everyone that helped me with sample collection, which was a lot of people, been absolutely invaluable. That's everything.
If you do have any questions, these are bloody marvellous, aren't they? I'm going to get the rest of my life wearing these. I tell you, I don't think my hearing's quite as bad as I thought it was. Certainly not with those on. But well done. Cindayniah, thank you so very much. If there's a question, we have someone at speed, not on speed, but Kathleen Gallagher is there indeed, who's able to come amongst us with great rapidity with a microphone. So at any stage for any of the chats, just stick your hand up and away we'll go. And well done. Very interesting. There's a lot of Irish connection in the room as well. We like that as well. I love all that from Connemara originally, but via the USA. So there you go. Thank you very much, Cindayniah. And well, yeah, we're about bang on time. Thank you very much.